Hey everyone, welcome back to the channel. Today we're going to explore more about RIP version 2, one of the most basic yet important routing protocols. I already built a network in Cisco Packet Tracer, which I will show you in a second so you can mimic at home and do the lab as well. I will walk you through the setup so you can see exactly how everything is connected. In this lab, we'll configure RIP version 2 so the routers can automatically share network information and make sure all devices can communicate with each other without manually entering every route. Here's the network I was talking about, and I wanted to show you how it looks in case you want to practice from home. And well, I'm pretty sure you might be asking yourself, well, why is this important anyways? Well, imagine you have multiple routers in a network. Each router connects to different networks, right? But they don't automatically know about the other networks without routing protocol. So you have to manually configure every possible route on every single router, and this could take forever. And it's really complicated if you ask me. That's where RIP comes in. It allows routers to automatically share network information with each other so they always know the best path to send data. Now, RIP isn't the most advanced routing protocol, so let me make that clear, okay? It's actually one of the oldest. But learning this first will help you understand how routing works, which makes it much easier to learn more powerful protocols like OSPF, which I'm planning to create another video about that later this week. And well, just for simplicity, think of it like learning how to ride a bike with training wheels before jumping into a motorcycle. So that's kind of like the way I want to see it. Once you understand RIP, you will have a solid foundation for more advanced networking protocols. And well, basically, what I will be showing you in this lab is three basic things. Setting up a default route. This tells routers where to send data when they don't know specific destination. Configuring network statements. This kind of lets routers know which network they should advertise to other routers. And finally, using passive interfaces. This helps improve security and efficiency by preventing unnecessary updates from being sent on a certain links. After setting everything up, we'll start test the configuration and verify that all routers can communicate properly. So stay here in this video because you will learn more. So this is the network that I already built out for this lab. And basically what we have right here is three computers, PC1, PC2, and PC3, three switches, S1, S2, and S3. Additionally, we also have three routers as well, R1, R2, and R3. R1 is connected to the internet, and we can see that it's connected to a web server. Just to start, let's make sure we cannot communicate between devices. Let's try pinging PC3 from PC1. Let's open PC3, go to Desktop tab, and click on IP configuration to find the IP address. We see that we have 192.168.510. We can copy and paste it. Let's open PC1 and ping PC3. Let's go to the Desktop tab and open the command prompt and run the command ping 192.168.510. We see that the ping was unsuccessful and we receive 100% loss. Now let's try to open router number 1. Let's go to the CLI tab and enter the command en or enable to turn on the privilege mode. To enter the terminal configuration, let's enter the command conft or configure terminal. Now, to create a default route for all internet traffic to exit the network through S001, let's enter the command IP route 0000001. You can pause the video and check the command. We get a notification saying default route without gateway if no point-to-point interface may impact performance. Now let's enter RIP configuration mode by running the command router RIP. We can see that we're now in the router configuration. Let's choose version 2 of the RIP protocol and disable the summarization of network by entering the command version 2 no auto summary. Next, we need to configure RIP for the network that connects to R1, S1, and R2 by running the command network 192, 168, 10 for this is for switch 1 and network 192, 168, 20 to connect to router number 2. The next step is to configure the LAN port without routers to prevent it from sending out any routing information. So let's enter passive interface gig00. Let's announce the default route configured to other RIP routers by entering the default configuration information originate. Now let's exit the configuration modes by running exit and again exit. Now we can save our configuration by running copy running config, startup config, and confirming our selection by pressing enter. Now we need to repeat the configuration for the router number 2 and the router number 3. So we're not going to repeat the same process in all the routers. Now that we configure all the routers, let's try to verify the configurations. Let's go back to R1, CLI, and enter the show IP route command to view the router's one routing table. And here we can see the codes here on the top and what each letter represents. Every network has an entry, so a default route here is also listed. It's right here. We can run the show IP route command also for for the router number 2 and router number 3, so we can check as well. We can see the complete listing of the networks and the default route right here. Now let's try to verify the connectivity. All the networks devices should now be able to ping each other and the web server. Let's open PC1 and ping the web server. Let's go to the desktop tab and open the command prompt and run ping 64.100.0.10. We see that we get a reply, so we understand that the connection is successful. Now let's ping PC3. Let's run the command ping 192.168.5.10. We see that the ping was successful this time, so that's good. So we completed the configuring RIPv2, and this is pretty much basically it.